Hello everyone, welcome to Career Launcher. So we are meeting for our second session on number system, and the agenda that we have kept for today is quite important and quite diverse. So we'll be looking at questions based on digit based problems. So problems in which some kind of conditions or some logics are being tested based on the digits of the numbers. So this is sort of a continuation of the basics, I would say. While in the first session we looked at a lot of elementary concepts, so we are sort of building further on that and focusing specifically on questions where digit is the uh, main concern, right? Okay, so well, it will be another fun session. I'm sure for you as well as for me. Because I would love to discuss the concepts, and for you, I would hope that you would try along with me, right? So let's start with the session, right? Here we go. As always, we look at some previous year questions as well as some other questions, some extra questions, right? Let's start. Here we go. All right, so here we go. The first question coming from a CAT 2018. How many two-digit numbers with a non-zero digit in the units place are there, which are more than thrice the number found by interchanging the positions of its digits? If there's a two-digit number, let's say whose units place digit is B and the tens place digit is A. So this is not A into B. This is a number representation of the two-digit number in its digit format. Obviously, since the condition is there on the digits of the number, so I will take the number as its with its digits being the variable. मैं number को ये नहीं बोलूँगा कि अच्छा let's say number is x, because then how do I apply the condition which is specifically focused on the digits of the number? So with this being the representation of the number, its value, because it's a we are working on the base system of 10, so the number, its value in terms of its value, that is 10 into a plus b is the value of the number, right? Now, so when we flip the number, right, that's what he's saying. When we interchange the positions of its digits, so the new number that we get is ba, right? And its value therefore is 10b plus a. So it is the value of the number on which the constraint is, right? That are how many numbers are there ab which are more than, means whose value is more than. Obviously the value is being referred to over here. So whose value, which is 10a plus b, is more than thrice this second number, the value of the second number, right? So thrice of 10b plus a. So that is a condition that we have to uh, check against and find out how many such numbers are possible. So what do we get? Let's see. So 10a plus b is more than 30b plus 3a. So 10 minus 3, 7a is more than 30b minus b, 29b. So we can say that a is more than 29 by 7 times of b. Let's do this fraction. What is its approximate value? 7 4 is a 28. So this is 4 1 by 7, 28 plus 1. This is 4 plus 1 by 7. 1 by 7 is approximately 1 by 7 is 14.28%. So 1 by 7 is approximately 0.14. A is more than roughly around 4.14 of B. इसके बाद क्या करेंगे? What we'll do after this, obviously we'll now make the cases by substituting the values of any one of the variables. Let's say I will pick and choose the values that B can take, starting from obviously 1 and onwards, because question specifically said that your tens units place digit of the original number B is non-zero, because what he intends to do is that the number obtained by reversing the digits is also a two digit number. नहीं तो अगर b अगर जीरो हो जाएगा तो जो रिवर्स करके नंबर बनेगा b है वो एक सिंगल डिजिट नंबर होगा, right? If you reverse the digits of the number 50, you get 5. So he doesn't want to have another the number obtained by reversing as a single digit number. So when b is 1, how many values can a take? A is more than 4.14. So A has to be at least 5, more than 4, 4.14, and it's a digit. So it can take the values 5, 6, 7, 8, 9. Remember, we are dealing with digits. A and B are digits. So they can only be in the range of 0 to 9, and 0 is not also possible for any of them. Right? So B being 1, A takes these values. You can imagine that as B moves along and takes higher values, it will be very difficult for A to take actually any real value, because A has to be a digit. So when B becomes 2, A is more than double of 4.14, 8.28. So more than 8.28, the only digit value it can take is 9. I think this is the limit, because clearly when B will be 3, A can't take any suitable value, because thrice of 4.14 is 12 plus, and therefore A can't take any suitable real possible value as a digit. So I guess that is all that we have. uh, the numbers that you have satisfying this condition therefore turn out to be 51, 61, 71, 81, 91, and 92. Six of them, right? So this was the first question that we looked upon, right? So the basic concept that was tested obviously was about the fact that when we take the digits of a number as variables, how does its value get defined, right? So a two-digit number AB is actually 10A plus B in value. A three-digit number, let's say there is a question something to do with that. Let's say ABC, A being the hundreds place, B being the tens place, C being the units place, has its value as 100A plus 10B plus C, right? So make use of that, and we can deal with such questions, right? What I'm trying to say, whenever there's a condition digits of a certain number, a two digit, a three digit number, etc., take the digits as the variables, and wherever you required, you use the value as we just discussed. Right. Perfect. So let's move on. Okay. Next one. CAT 2013. I like this question a lot. There's a lot to learn. This sort of a question is called an alphanumeric puzzle. Let's see. Let PQ rest U and V, seven variables he has mentioned, represent the seven distinct digits from 0 to 6. Not necessarily in that order. So he says there are seven digits. They take these values 0 to 6, all different. If PQ and RS, so here he refers to two digit numbers. PQ and RS are both two digit numbers adding up to the three digit number TUV. Find the value of V. This is not a question that you can algebraically solve. It's an alphanumeric puzzle. He's trying to say, equation wise, PQ plus RS is TUV. You have to do some number fitting over here. You have to do some substitution of digits. It's not a question that you can solve. Acha, I have this equation PQ plus RS equals TUV. Because PQ, it's not P into Q. RS, it is not R into S. It is 10P plus Q the number, and 10RS plus the number, which add up to become 100T plus 10U plus V. You to start thinking. For example, this three-digit number TUV, just think about this. Two-digit numbers, how will they add up to become a three-digit number? Think about that. If you're going to get a three-digit number, which digit are you certain about? Which digit can you be sure about? Means, just think about this. PQ and RS both are two-digit numbers, well, so therefore they are at the most. I mean, in this case, because of the range of values, actually none of them can be more than 65 ever, because of the range of the digits given. And then once the one of them is 65, the other can be at the most 43. 65 and 43 is what, 105? Sorry, 165, 43, 108. What I'm trying to say, what can your t take? What value can your t take? Just think about that. It can obviously be only one, right? एंड चाहे तो मैं तो कह रहा हूँ अगर ये रेस्ट्रिक्शन भी नहीं होती, इवन इफ दिस वाज नॉट देयर, स्टिल 99 plus 99 is 198. You cannot ever exceed the range of 100 something, right? So t is surely one. What I'm trying to say, you're thinking of these digits taking certain values, right? This box and these two boxes, these are your two-digit numbers adding up to become your three-digit number TUV. Just think about what you can substitute here. I'm saying this can only be one, nothing else. Right? I've just put some boxes to represent these digits. PQ plus RS is TUV. Now, next thing is, if this is one, what must have happened over here? What must have happened over here in the sense, what could be the two digits at the tens place of these numbers? Now, what I'm thinking is, in this addition, from the units place, when we do the addition, either there is a carry or not. Now, think about this. Do you think really that we can afford to keep a carry? Let me explain. Just think about this. अभी जब मैंने आपको लार्जेस्ट वैल्यू के बारे में सोचने की कोशिश की थी, आई वाज सेइंग एट द मोस्ट आई कैन थिंक ऑफ डूइंग 65 plus 43 108. Just think about this. 108, you are barely able to cross the limit of 100. My point is, यहाँ पर 6 और 4 आए तो यहाँ 10 बनेगा, तो ये 10 का 1 यहाँ आएगा, ये 0 बनेगा. Do you really suppose it could be the any other way? In the sense, in this addition, I'm not saying this is going to be 65 plus 43 108. Obviously we can't have 8 as the value here, but my point is because of this addition, it is very clear that even by keeping the largest digits here, 6 and 4, I mean, they are not the largest, but I have basically maximized the tens place, the overall value. In fact, you can even do something else. I mean, you can do, let's say, 60 if you want to take 6 and 5 here. Okay. So 6 and 5, and then 4 and 3 here, 65 plus 53. Even that is just what? 117. So my point is, यहाँ तो यहाँ से कैरी होगा या नहीं होगा? Can we really have a carry? No, because in order to have a carry, you need to keep something here which is more than 10, for which you need to keep at least something like 6 and 4. But you can see that in order to actually have 1 as the carry in that, from the tens place to the hundreds place, you need the 6 or 4 or 5 over here. You cannot therefore afford to have a carry. You cannot. Means you cannot keep large numbers over here. So we are sure there will not be a carry. Now, so the carry must be from here, right? यहाँ से carry आया होगा 1, यहाँ पर carry जरूर आया होगा, तभी ये 1 आया है. Now, so यहाँ से carry नहीं आया है, but यहाँ से carry आया है. अब यहाँ पर जो addition होगी, just think about this. I know that the digits over here will not create a carry. So whatever is the sum here should happen over here. Now what we're left with is 0, 2, 3, 4, 5, 6 as the remaining digits to be arranged. We need some relation over here, these three digits, to take such a value such that these two digits exactly add up to this value, right? Now think about 0. Where can 0 come into picture over here? Do you really think we can keep 0 somewhere in these three positions in the units place somewhere? Obviously no. Why? If you have 0 here, whatever is the digit here must repeat here. Impossible. If you keep 0 here, let's say then you keep 2 here, then you will again have 2 over here. So 2 can't, so 0 can't come over here anywhere, and 0 also can't come over here as the resultant over here. Why? Because 0 coming over here implies you are having a carry, because 0 means it's 10, right? You can't have 0 plus 0 as 0. So what I'm saying is 0 must come here somewhere in the tens place. either in these two or in the resultant. But these two can't be 0 because you need a carry. So the only place where 0 can come is here, which means this addition must add up to exactly 10. The only way that can happen is 6 plus 4 10. You can't have 5 plus 5 10. So in certain order, these two are 6 and 4. Let me put this arrow sign over here to say, I don't care where is 6, where is 4. All I care is 6 and 4 should be at the tens place. So 6 is gone, 4 is gone, 0 is gone, 2, 3, 5 is left. We were saying we need some relation that these two add up to this, which does get satisfied. 2 plus 3 does equal 5. So that is what we have to finish our alphanumeric puzzle, right? Again, I don't mind where these 2 and 3 are, but eventually the value of v which he's asking is always 5, and that is your answer, right? So this is what it is. uh, so uh, right, so alphanumeric puzzles are very interesting, and I would say that questions on this have been asked, right? You can see this one, and there was actually one alphanumeric puzzle came as an LR set in one of the recent year problems. If I can recall, it was somewhere around 2019 or so, I guess, right? It was a huge alphanumeric puzzle, came in a DILR section. Just check it out, right? Okay, so this was this, people. Let's see the next one. No, CAT 2019. Let's see what this question has for us. In a six-digit number, the sixth, that is the rightmost digit, is the sum of its the first three digits, and so on. Some conditions are there about the digits of a six-digit number. Nothing about this. You have a lot of conditions about certain digits adding up to the value of another digit in these amongst these six values. So again, I'm just keeping some boxes to represent these values, right? Let's put this down. What I'll try to do is I'll try to find pinpoint some conditions and define the digits in variable form. The first condition that he says is not what I would want to start from, because something is the sum of three other values. I would want a more a better relation where less variables I need to take. यहाँ पर मुझे तीन variables लेने पड़ जाएंगे, right? The fifth is the sum of the first two. Okay, I can start with that. मैं इसको A और B ले लूँगा, perhaps. The third is the equal to the first. Okay, the second digit is twice the first. Now that is very crucial. That is very, I think, useful. The second being twice the first, and the first two adding up to the fifth one, right? Fifth is the sum of the first two. Fine, I'll start from here, this linkage. So if I take this as A as a digit, this is 2A. The second I have made use of this thing. Second is twice the first. Now fifth is the sum of the first two. So this fifth is the sum of the first two, which is A and 2A, 3A. Okay. The third is equal to the first. Very nice, right? This one. So third is equal to the first digit. So this is also A. That brings me to the first condition, actually, right? That the sixth digit is the sum of the first three. So first three add up to 4A, A, 2A, and A. 4A, that is the sixth digit. Only this one is left. And the fourth digit, which is left, is the sum of the fifth and the sixth. 3A and 4 is 7. So in terms of a single variable A, I have defined the digits. Since these are digits, all of them, A has to be a natural number. A can take the value 1 or 2 or 3 or 4 or dot dot dot, but actually it cannot cross the level of 1, because 7A is a digit. If A is 2, then 7A is 14, and 14 is not a digit. So A cannot take any other value except 1. And therefore, actually, the number that we are talking of is a fixed value, which is 121734. That is the number for sure that he's talking of. He's asking for the largest possible value of the fourth digit. Actually, it is fixed, because There's no largest possibility, there is a fixed possibility. The fourth digit can only take the value of 7, right? So actually this was just a question about uh, just summarizing or capturing these conditions and defining the digits in terms of as least number of variables as possible. So you saw how I picked the conditions such that I only managed to define all the digits using a single variable, and then I thought about अब क्या करें, अब उसको वैल्यू कैसे असाइन करें उस वेरिएबल को। तो यही समझ में आया कि वो वन ही ले वैल्यू ले सकता है और कुछ नहीं हो सकता है, राइट? ओके people, so again I hope that you're getting the things right. Each question is bringing its own logic. मैं आपको सारे तरह के डाइवर्स लॉजिक्स दिखा रहा हूँ, right? That's the idea on which we are working, right? Let's see more. Let's see the next one. Okay, so last year's problem. Let's see now. So, well, you can see very neat and clean question. The sum of all the digits of this number represented in the power form with huge powers of 10 and a 3-digit number subtracted from the sum of these two powers of 10, right? So obviously we have to sort of do some this addition and subtraction. Obviously we can't write the full all the digits. It's 20 because this is a 26 digit number, 10 is to 25. It is 1 followed by 25 zeros. सबसे पहले तो लोग इसमें मिस्टेक कर जाते हैं कि 10 is to 25 what people write sometimes is 1 followed by 24 zeros. So just don't do that mistake, because 10 square is not 10 but 100, 1 followed by 2 zeros. 10 cube is 1000, 1 followed by 3 zeros. So 10 is per n is 1 followed by n zeros. Now what I'm thinking is this 10 raised to 50 is a huge lonely number that can sit away. अभी हम इसको बाद में add कर लेंगे. This will just create a 1 in the addition at the left as the leftmost digit, right? हम इस सब्ट्रैक्शन को केयरफुली हैंडल कर लेते हैं. 10 रेज़ पर 25 माइनस 123, फिर उसमें फिर 10 रेज़ पर 50 इजीली फिर ऐड कर लेंगे आखिर में. सो आई विल राइट माय 1000 dot 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 lots of zeros, and this is 10 raised by 25, right? This is 10 raised by 25, so these are 25 zeros. Let me mention this is 10 raised by 25. So from this I'm subtracting 123. Perfect. So obviously I'll need to do a carry, and for that carry will come all the way from here, and this will be 10 and this will cross, and all these will be nines. So these will be 9, all will be nines that are ready to now do the difference, and then we are now doing the subtraction. So this is now actually a 25 digit number that I am left with once I have done that carry, right? These, right? सो अब मेरे पास जो सब्ट्रैक्ट करके आएगा वो एक 25 डिजिट नंबर आएगा, राइट? फॉर श्योर. सो दिस इज 7, राइट? एंड दिस इज 7 as well, and this is 8, and then all these are nines. All these are nines, 999, right? And therefore so these three digits are something extra. These are nines. So how many nines are these? Because this was a whole 25 digit number, these are three digits, so these are 22 nines, and then these digits are there. Now इसमें जब मैं 20 raised by 50 ऐड करूंगा in this number, obviously I'll just have a 0, I'll just have a 1 as the preceding digit, right? So eventually the number that I will have when I will add the number that I actually wanted to also add in this summation, जब इसमें मैं ये नंबर ऐड करूंगा तो यहाँ पर जस्ट यही होगा कि this will be 000 and there will be 1 preceding it if I'll do this. So basically I've done this plus this minus this is this. So the sum of the digits is what he is asking from me. So that becomes this 1, this lonely one sitting on the leftmost place, and then these 22 nines. So 9 plus 9 plus 9 plus 9, 22 times, and then this 8 and 7 and 7, that is what I have. 1 plus 22 into 9 will be 180 plus 18, 198. And 8 and 7, 15 and 7, 23. Oh, sorry, 15 and 7, 22. So this will be 1 and 1 and 198, 199 plus 22, which is 221. Right? Perfect. Yeah. तो हम क्या कर रहे हैं? Actually, we are doing third grade maths if you think about that. But actually, it's not really a question that a third grader can actually handle. But yeah, I mean, we are doing addition subtraction, and it was fun, right? So I think so you can see, I mean, such questions are there which make you think, अच्छा ये हमसे करना क्या चाहते हैं? You see, this exam is so fun. I mean, if you just try to understand, he is asking from you some basic logics, right? अब आप इस क्वेश्चन को कौन सी कैटेगरी में डालोगे, right? This is a question of numbers, and just deal with it. I mean, so I think the main thing was to just understand that जो main subtraction हो रही है वो 10:25 और 123 में हो रही है, right? क्योंकि that is a smaller part, तो पहले वो subtraction किया और फिर उसमें लास्ट में 10⁻50 भी जोड़ देंगे, right? चलिए और देखते हैं. Cat 2017 was one of the monumental cats, both in Quant and LRDI sections, right? Means a landmark exam with a lot of diverse logics and intensive. So this was one of the very interesting, unique questions that was asked. Let's see this. The numbers 1, 2, dot 9 means 1, 2, 3 up to 9 are arranged in a 3 by 3 grid. A 3 by 3 square grid will have 9 numbers, 9 values. So will you be using them in such a way that each number occurs once and the entries along each column, each row, and each of the two diagonals add up to the same value? The second thing is the most important, crucial thing. So we have a 3 by 3 grid, something like that. Now, so यहाँ तक तो सब ठीक चल रहा था कि 1 से 9 अरेंज करना है, कोई नंबर रिपीट नहीं होना है, तो 1 2 9 are arranged over here, right? Now the next condition is actually something very crucial, that the entries along each column, each row, and each of the two diagonals add up to the same value. Now think about this. We have 3 columns, we have 3 rows, we have 2 diagonals, right? Each of the entries along them add up to the same value. Each of the entries along each column, there are 3 entries along each column. There are 3 entries along each row. There are 3 entries along each of the 2 diagonals also. Think about this. The sum of all the 9 numbers is a fixed value, which is 1 plus 2 plus 3 up to 9, which is 9 into 10 by 2, which is 9 into 5, 45. So 45 I know is the sum of all the entries. There are 3 rows. There are 3 columns. So the sum of each row and each column is the same. So therefore this 45 has to split equally among them. So each of them add up to 45 divided by 3, which is 15. So if I add, let's say, these 3 values, if I add, let's say, these 3 values are along the diagonal, or the other diagonal one, these 3 values, they will add up to always 15. Now, then he says if the top left and top right entries of the grid are 6 and 2 respectively, we have to find the bottom middle entry. Top left is 6 and top right is 2. Now I've just concluded 15 is the sum of all the entries along each row and column. Along the first row, therefore, I can fill this third value. 6 and 2 is 8, 8 and 7 is 15. I'm asked to find basically this value. This is my focus. So after filling this 7 comes to the focus, the second column. So now I know the sum of these two numbers. What can I do with that? I can try to do some number fitting, obviously. 2, 6, 7 are gone. 7 plus the other two things that I have to add up, it should become 15. So other two values should add up to become 15 minus 7, 8. So how can I have 8? I can't do 1 plus 7, 8. 7 is already used. I can't do 2 plus 6. 6 is already used. The only way I can do is 3 and 5. but in what order? The question is a theta question. अगर मेरे पास 4 ऑप्शंस होती और 3 या 5 में से एक ही ऑप्शन होती तो मैं उसको मार्क करके आ जाता, बट दिस इज अ theta question. What do I do? I do number fitting. I do hit and trial. I try to satisfy other things as well along with. बस ये तो नहीं कि 3 5 यहाँ रख दिया. You have to also ensure that along each of the other rows and columns and the both the diagonals left out, you need to have the sum of 15. So think about this. uh okay, so I am putting, let's say, 3 here. If I put a 3 here and then a 5 will come here, let's see. Think about this diagonal. 6 and 3 is 9. I need something over here to add up to 15. 6 plus 3 9, 9 plus 6 would be 15. I can't repeat a 6, so this can't be 3. So I guess the only way we can work out is this should be 5 and this should be 3. I think we can safely mark the answer as 3. And for the completion of, the for completely understanding, I'll fill the whole grid for you, and we can easily finish that. 6 plus 5 11, 11 plus 4 15 in this diagonal. 2 plus 5 7, 7 plus 8 15 along this diagonal. Here 8 and 6 14 and 1 is 15. Here 2 and 4 6 and 6 and 9 is 15, and I think that is it. Yeah, so you can see, right? So the whole grid can be arranged. Answer is 3. Right. So, well, this was fun. I'm saying numbers are fun. Right. I mean, you have to just be open-minded. You can get any sort of a new question. Right. Will look like a puzzle. Right. And just think. Okay. So we'll look at some more questions now. We have looked at PYQs. Let's look at some extra questions. Let's practice. Here we go. Well, if f of n is equal to sum of digits of n, then we have to do this summation of all the digits of these numbers from 100 101 up to 199. So these are, I guess, 100 values from 100 to 199. We have 100 numbers, right? So I think this is just, we have to, we'll do it. I mean, so you have 100 101 102 103 and so on, and up to 199, right? So dot 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 191 192 190 dot 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 198 199, right? Hundreds place, all of them are 1. 100 times 1 100. The summation of all the hundreds place values is simply 1 repeated 100 times, so that will be 100. These are 100 numbers starting from 100 up to 199. Tens place digit, so there will be 10 times a 0, 000, then 10 times 1, 110 to 119, and so on. So now all the 10 digits will appear, even 9 will appear 10 times from 190 to 199. So 10 times of 0 plus 1 plus 2 plus 3 up to 9. Sum of the first 9 numbers, 0 is 0, 1 to 9 is 45. So this is 450. I think the same story is going to be there for the units place digit as well. The same story. I mean, it's the order is a different, but still 0 will occur 10 times at 100 110 120 and so on. 1 will appear also 10 times at 101 111 121 and so on. So the same story, 10 times each of the digits is going to occur. So again the same thing, 10 times of 0 plus 1 plus 2 up to 9, the same thing, 450. And that should be my answer, 100 plus 450 plus 450. Yeah, so that's it. This is 1000, right? This is 900 plus 1000. Well, that's it. So, right, I'm trying to bring across diverse logics, right? Here we are dealing with, well, this, just add up the digits, just see the pattern, right? Okay, well, next one. Let's see. Look at this one. The 101st digit after decimal point in the value of this sum of these fractions. So let me explain the logic behind this question. You should know that whenever you have uh, fractions in which the denominators are 10 is to power n minus 1 kind of thing, like 1 by 9, 1 by 99, 1 by 999, 1 by 9999, then what is the pattern in the decimal representation of these numbers? 1 by 9 is 0.111111, right? 1 by 99 is 0.010101 dot dot dot. 1 by triple nine is going to be 0.001001001, and so on. There's a pattern, right? 1 by 9999 will be 0.0001 repeating, right? This is zero point 0.1 bar. This is 0.01 bar. 0.001 bar. Bar means repeating, right? So 1 by 3 and 1 by 9 we can easily handle. Now coming to these two fractions 99 and 101, if you take the LCM of 99 and 101 in the denominators, since they are co-prime numbers, their LCM will be 99 times 101, which is nothing but 9999. And as per our pattern, 1 by 9999 is therefore going to be 0.0001 bar. I think the question is therefore done. So 1 by 3 plus 1 by 9 we can handle separately is going to be, well, 3 plus 1 4 by 9. Since we know 1 by 9 is zero point 0.1 bar, so 4 by 9 is going to be 0.4 bar. So this value is 0.444 repeating infinitely. Now this value is 1 over 99 plus 1 over 101. So taking the LCM, this is 9999, and then 101 plus 99, so 200 by 9999, 200. And therefore this is 0.0001, so 200 times of that, so 200 by 9999. So just multiply this with 200, so 1 into 200 is 200, so this is 0.0 uh, 0.0201 bar, 0.0200 bar, right? Just simply multiply this with 200, so you get 0.0200 bar, means this will be 0.02000200 and so on. And therefore you put this over here and you add, so you have, so basically the pattern is only of 4 digits, so we'll just add 4 times and that will repeat. So this is 0.4444 repeating infinitely. This is 0.0200, and this pattern will then repeat infinitely. So the pattern that we get is therefore 0.4644 repeating infinitely, and then again it will be 4644 and so on, right? So this value is therefore finally coming to be 0.4644 bar. That is what this number is. So this logic that I discussed over here, is being tested in this question. Now, so therefore, 101st digit. First digit is 4, second is 6, third is 4, fourth is also 4, fifth is 4, sixth, right, is this, seventh is this, eighth is this, means 1, 5, 9, and so on. A multiple of 4 plus 1, that place value will always be 4. Second, sixth, 10th, a multiple of 4 plus 2, they will always be 6. Multiple of 4 plus 3, 3, 7, 11, and so on, they will be 4. Multiple of 4, they will also be 4. This 101 is a multiple of 4 plus 1. It's 100 plus 1. So it should be the first digit over here, which is 4. Right? That's it. Okay, so therefore, do note this property or this pattern in the representation of the recurring form of the fractions. involving a power of 10 minus 1, right? 9, 99, 999, right? कभी भी कहीं भी कुछ भी कॉन्सेप्ट यूज हो जाता है, राइट? चलिए, so I hope this has been fun for you people, and let's have more fun with the next one. Okay, so well, there's a dialogue going on. Let's see. Following is a dialogue between Krish, a teenager, and his grandfather. Nice. Grandfather says, "My age is a two-digit prime number." All right, fine. Krish says, "My age is a sum of the digits of your age." जैसे उसने कंडीशन डिजिट्स के हिसाब से बोली, तो I will take the age of the grandfather to be the two-digit number AB in the digit form. Means the value of that being 10A plus B, right? So if the age of the grandfather is AB, which means in value terms 10A plus B, so Krish is saying my age is A plus B, the sum of the digits of your age. Grandfather is 10A plus B. Krish is A plus B. Grandfather says one more statement because abhi to we don't have any numerical conditions to be able to record. Question is asking for the age of Krish. No option is saying cannot be determined. The difference of our ages is an odd perfect square. Now, so I hope we can do something from here. The difference of our ages, so subtract these two, 10A plus B minus A plus B, you have simply B cancels, you have simply 10A minus A, 9A. A is a digit. 9 into A. Now this is 9 into A. Because this is that's exactly what it is. It's an odd perfect square. 9 is already an odd perfect square. 9 is already 3 square, right? A could be therefore another perfect square. So A could be well to begin with 1, but I don't think so. A person in his teens can be a grandfather. Yeah, right? You can't have a grandfather whose age is 11 to 19 range, right? So, well, that is biologically impossible, and mathematically, I don't think so. It will satisfy the constraint also because Krish, uh, the thing is that I mean, can you have A as 1? Impossible, right? Not possible. So the next possibility is A is the next perfect square of an odd number, which is 3 square, and it can be 9, right? So we need to find the age of Krish, uh, right? So A can't be 1, impossible. You can't have grandfather and Krish to be the same age because अगर आप A को 1 ले लेंगे तो क्या हो जाएगा? If A is, I mean, right, it's not going to be possible. I mean, mathematically इस क्वेश्चन की कंडीशन भी सेटिस्फाई नहीं हो पाएगी because A plus B won't be a two-digit number because question is saying Krish is a teenager. I mean, if you want a more rigorous explanation, I mean, आप बोल तो सकते हो सर ये तो मैथ्स का क्वेश्चन है. कई बार ऐसा होता है ना कि मैथ्स में कुछ अजीब सी बातें हो जाती हैं जो वैसे पॉसिबल नहीं है. So even as per this question, Krish is a teenager. So if you take A as 1, then A plus B can't cross the limit of 11 because Krish is a teenager, right? So A can't be 1 for sure, and A is 9. So therefore, now coming to the fact that remember grandfather was saying my age is a two-digit prime number. We have not yet used this constraint. So now grandfather is AB, A is 9. The only two-digit prime number with starting with 9 is 97. So I think that is done. Grandfather is 97. Krish is 9 plus 7, 16 years of age. 97 minus 16, the difference of their ages is 81, which is 9 square. All the conditions are being satisfied. So our Krish is 16 years old. Right. So I guess we have looked at 8 diverse logics, right? All having the central theme of something to do with digits, right? And we'll continue this, and we'll come up with more number logic questions next time as well. Till then, keep on practicing. Thank you so much, people. I'll see you again next time. Thank you.